All right, welcome back, Hononegah, Algebra 1. 6.5, today we're going to talk about solving exponential equations. Now, when you get into Algebra 2, we start talking about unlike bases and things like that. But for our purposes in this class, we're talking about like bases. So getting the bases to be the same. So that is the major point of today. And the major topic that we'll have to talk about is anytime you have an x as an exponent, one of the ways of solving exponential equations is if you can get the bases to be the same, then the exponents, you can solve the exponents. So if the bases are equal, you can solve the exponents. So if the bases are equal, the exponents are also equal, or whatever the exponent or whatever the sign is in between. So if I had 3 to the x power equals 3 to the fourth power, then x would equal 4. Because the bases are the same, then the exponents are, again, whatever the symbol is in between. And in this class, we'll do a lot of equal signs. So if the bases are equal, exponents will then be equal. The key part about this is the bases have to be the same. So 3 raised to the x plus 1 equals 3 raised to the fifth, then x plus 1 would equal 5. And then you just go back to your Algebra 1 skills from Chapter 1 and solve. So this is 6 to the first power. So since 6 to the first is equal to 6 to the 2x minus 3, then 1 must equal 2x minus 3. So I'm going to add 3 to both sides and divide by 2. So again, just doing your solving skills. Next one, it gets a little more complicated just because the exponents get more complicated. 2 raised to the 3x would equal 10 raised to the 3x would equal 10 raised to the 2x plus 3. Then 3x must equal 2x plus 3. So again, using our solving skills from back in chapter 1. Hit pause, see if you can get this one by yourself. All right, welcome back. So 7 raised to the 3x plus 5 equals 7 raised to the x plus 1. So again, since the bases are the same, I'm going to subtract x. I'm going to subtract 5. And I'm going to solve. So the key to all of this is if the bases are the same or the bases are equal, then you can solve the exponents. So in the next one, the bases are not equal. So let's talk a little bit about this. You can never increase something, but you can always break something down into a smaller value. So instead of 125, I want to break that down into something smaller, meaning I want to make it instead of 125, 125 is same as 5 to the third power. So you're going to have to know your exponents just a little bit. And if you don't know, you can always do a factor tree. A factor tree will break something down into smaller values. So now the bases are the same. 5 raised to the x equals 5 raised to the third. Therefore, x must be 3. So 4 is the same as 2 squared. Now this gets us into another property that we learned in section 6.1. So I changed 4 into 2 squared. From section 6.1, it said if you have a power raised to another power, you can multiply the powers together. So now bases are the same. 2 raised to the 2x equals 2 raised to the x minus 3. Set the exponents equal to each other, and x would equal negative 3. So all of this is about getting the bases to be exactly the same. So this one is as hard as it gets. You want the top of the mountain here. 9 is the same as 3 squared. 27 is the same as 3 cubed. So notice that I broke both sides down into smaller amounts. Power raised to a power. Because you're taking 2 times x plus 2, you would need to distribute that. 3 raised to the 3x. Finally, bases are the same. I can then solve the exponents. So if I subtract 2x from both sides, I get x to be 4. That question right there is as hard as we'll make this on a test or quiz. Now, if you have a value that is a fractional value. We're going to change this so the bases can be the same, but it's literally the negative power. So instead of a half, this is 2 to the negative first. So I'm going to pause for a second there and let you think about that. Anytime you have a 1 over a number, it's to the negative first power. So I'm going to make it back into a number that's now greater than 1. What happens when I have a power raised to a power? I multiply the two powers together. Bases are the same. So now negative x would equal 2, x would equal negative 2 is the answer. So instead of that 1 over 64, I'm going to change it to 4 to the negative third power. 64 is 4 to the third, so 1 over 64 is 4 to the negative third, once the bases are the same. And again, that is the key to today's lesson. Once the bases are the same, exponents can be solved. So if I subtract 1 from both sides, x would equal negative 4. So now we have a couple of U tries again. So hit pause. And welcome back. All right, here we go. So 9 is 3 to the second power. So I broke down 9 so that it's a smaller value. Power raised to a power, I multiply the two powers together. So I took 2 times 2x. Now the bases are the same. Anytime the bases are the same, the exponents can be solved. So I'm going to subtract x and divide by 3. So again, the key of today is that the bases are the same. In this case, the next one, bases are not the same. 27 is 3 to the third power. 1/3 is 3 to the negative first power. Anytime I have a power raised to a power, I multiply the two powers together, and now I'm to where I want to be. Once the bases are the same or equal, I can then solve the exponents. So I subtract 1 and divide by negative 1. X would equal negative 2. So the key to today is being able to break down the numbers into getting the bases to be the same. This one, they're adding a step, and they're adding some degree of difficulty here, to be honest with you. This is probably going a little bit above what I would do even in my honors class, but we're talking about a situation in which you're going to divide by 12 first. Now, the bases are the same, so I can solve their exponents. So the key to this is getting the bases to be the same. So I'm going to divide first by that 2. Bases are not the same. That's a key today. So I need to break this down into a smaller amount. 64 is 4 to the third. And you may want to actually have a list of all the, squared and cubed, and maybe even to the fourth power a little bit. So that would be something that we might want to consider giving out to the students, so that we have something that they can reference. So I will probably talk to the teachers about maybe getting you guys a list of some of the most basic cubic and quartic and square terms. So next one, radicals. Now this gets us into earlier in this chapter. I'm going to change this square root of 5 into 5 to the half power. So changing it from radical form to exponent form. Now that the bases are the same, I can solve. Now I'll accept also 1.5 here, but I can solve the exponent. So this is probably as hard as I could possibly make this. I wrote it as 3 to the 1/5 power. What happens when I have a power raised to a power? I multiply the two powers together. And so now once the bases are the same, I solve the exponents. Subtracting 1. And some of you might want to get rid of the fraction first, but this is negative 4/5 x. Oops, sorry. Negative 4/5 x equals 3. So if I multiply both sides by 5, I get negative 4x equals 15, and divide by negative 4. X would equal negative 15 fourths, or if you wanted at the decimal, negative 3.75. So if you have a radical, you're going to change it into exponent form. Homework assignment is out of the book. Please double check your Google Classroom that this is the assignment for section 6.5. And if you have any questions, please make sure you talk to your teacher, and good luck.